How to grade your AI agents like a pro in 5 minutes using Agent Evals. Hello everyone, this is the third video that I'm making about Agent Evals and how to evaluate your agents. Basically how to make your agentic workflows more reliable, which is basically the biggest problem these days in terms of deploying agents. So many people speak about deploying agents and building agents, but more often than not, these are just simple workflows, which is fine when you don't need agents or you don't need LLMs in the workflow. There's no reason to use them. But when you want to include LLMs and want to add like a dynamic component because you want the LLMs to do some decision making, sorry. So you need to have Evals as well in your workflow. So it seems like the other two videos didn't gain so much traction, which is fine, but I still wanted to do this third video about Evals because I think it's very, very important for those of you who are interested in building something reliable. So most of the video today is going to be based on Agent Eval, which is a library that was published by LangChain. I'm going to share the link in the video description. If you want to learn more about Evals, so check out my two recent videos. I'm going to give a brief overview and then dive into a few things that I think are very important, and hopefully if you viewed these 3 videos you get a better understanding of how to build a reliable agentic workflow, which is something that most people just don't do. So let me make this bigger. So as I said, the issue today, why agentic workflows, why AI agents are not necessarily adopted by enterprises or businesses is sometimes we have latency issues, sometimes we have cost issues, but more often than not, it's just an issue of quality, lack of reliability. Businesses are not willing to take the reputational risk or risk in general that the agentic workflow will fail. This is why Evals and the ability to analyze your agent is so important. So let's just clarify the jargon. Agent, I hope you know what is an agent, so we will skip that. Trajectory is the step-by-step path the agent takes while thinking and acting. It's like the moves that you're making on the chessboard. So it's the tool calling, what he wrote, etc. Evaluator is like a robot teacher that looks at the trajectory, the steps that the agent did, and then gives it a grade. So it can be a binary grade, good job or try again, or it can be like a Likert scale between 1 to 5. Tool call, you probably know what it is. So basically when an agent asks an outside tool for help, similar to grabbing a calculator during a math exam. And now this is so these are like 4 terms that you're supposed to know, and these are new terms. So we have different types of rules that the robot teacher, the evaluator, can use when checking the agent steps, the trajectory. So we have the strict, the unordered, the subset, and the superset. The strict means that every move must match, and I will elaborate in a moment with another example. Unordered means that moves can be in any order, but they must match. Subset means that only some moves must appear, and superset match means that no extra moves are allowed. And LLM-as-judge, another thing that we will discuss in this short video, is instead of hard rules, we can use LLMs to judge the trajectory and understand and basically grade the agent. And again, it can be a Likert scale or just a binary. Now the big idea is, imagine you are programming a robot detective to solve mysteries. You care about 2 things. Does it end with the right answer, and did it follow the right steps? Because you want to make sure that the robot detective didn't do any crazy things such as kicking doors open or chasing wild goose. So let's say you have an agent you want it to bring you the correct answer, but let's say you want to scrape a specific database. So yeah, you want the database to be scraped in a CSV or in a JSON file, but the steps that he followed are important as well, because let's say it did some illegal scraping without logging in or without rotating the IPs. So this is important because maybe the bottom line can be fine, but the steps along the way can be incorrect or illegal. So this is why it's important also to know the whole trajectory. Now, because the robot reasons on its own, it's an agent, you don't control what it will do, because it is operated by an LLM, and an LLM is non-deterministic by nature, it's stochastic, so you can't predict every path, so you need an ability to analyze the path that it took, the trajectory. So Agent Evals by LangChain gives you pre-made robot evaluators that watch the detective moves, the trajectory, and automatically grade them. Now, we're going to dive a bit deeper into what I started discussing before. So we have 4 different match styles. Now, think of your agent as a student who has to show their work on a math problem. The evaluator is a teacher checking the steps. Now, we have the strict match. So what the teacher checks is you want to see that every single step must appear in the same exact order. So let's say we have a math problem. There are certain steps that needs to be taken in order to solve this, and the teacher wants to see that the student follows them one for one. So key level analogy, write the long division steps exactly like on the board. And you want to use this when you want a 100% repeatable script. So for example, a compliance workflow. The next style is an unordered style. So the same set of steps must appear, but the order doesn't matter. So show me you did add, subtract, multiply, any sequence is fine. When to use this? Steps are independent, e.g. gather 3 facts, the order is irrelevant regarding how you gather the facts. The next style is subset. So the student must include at least these key steps. Extra steps are allowed. So an example, an analogy is, be sure you wrote the hypothesis and conclusion. Extra notes are okay. So when to use this, when to check the trajectory for a subset. So when you only care that certain safety or logging calls have happened. So you look at the trajectory of the agent, the output of the agent, and all the steps that he did. And all you care that he did, for example, correct logging, that he didn't disclose the API keys, etc. As long as these steps were taken, you're happy, you're fine. And the next style is superset. So the student may do only these steps and no extra. So basically the analogy says follow the recipe and don't add mystery spices. And when to use this, you want to ban risky or expensive calls. So for example, no delete user, for example. So there are just stuff that you insist that will happen, and if a delete user tool call happened, this means that we're out of the superset, so which will basically the evaluator will return a false. Now we have also tool arguments match modes, which basically steps in the trajectory. Agents often call tools with arguments, and sometimes we just want to make sure that the tools, for example, were called, but sometimes we are also interested in making sure that the tools were called correctly with the correct arguments. So the exact arguments must be identical, for example, like here. Or if we ignore the arguments because we don't care which arguments were passed, but we just care about the tools. And we also have subset and superset and a custom function. Now, you can think of the match evaluators as running an automated domain-specific diff. So it's like when you run a diff between your files. It's kind of similar, but just with comparing the trajectories. So I have here like this table that shows the difference. So what a classic file diff does, so we have lines of text that are compared to a saved file, and the match evaluator is similar. So we have steps that are compared to a golden trajectory. And now a golden trajectory is something very important that I didn't mention, which I probably did. So let's say we have an agent that is supposed to go to a landing page, scrape all the data, then send the data to an LLM, which is another copywriting agent, and the copywriting agent must send us back a headline that is 90 characters long, and it must also include the word limited time offer. So we know this is the golden trajectory. We know these are the steps and how we would like the trajectory to look like. And now when we run this agent again, we basically compare the output of the agent, the trajectory of the agent, to the original golden trajectory, to what we actually would like to see in production, repeatable. So this is the golden trajectory, and it's important. Now, in terms of output, so a file diff, what it does, it just shows us which lines were added, which were removed, which were reordered. And over here, the output that we are going to get by the evaluator is a pass-fail, or a Likert scale, etc. Now, let's see how each rule changes the diff. So I think I might skip this because it is becoming a bit longer, and this is a bit of redundant because I basically already explained this. Now, moving almost to the LLM-as-a-judge. So LLM-as-a-judge isn't necessarily like a diff checker. So basically you hand the entire run to another model. Let's say my agent is operated by O3. I can take the output, the whole trajectory, and send it to another model, let's say Claude Opus 4, and ask it to grade the story using this rubric. And obviously, like we discussed in previous videos, we can decide about different evals, so hallucinations, recall, evals that are specific to the use case, etc. So this is LLM-as-a-judge, and we already discussed this. I just want to mention that it's important I think it's important to mention that many people are discussing these days about using different models for evaluation. Should you choose a reasoning model for evaluation or non-reasoning model for the evaluation? What is the difference, etc. There are still no hard conclusions regarding is it better to use a different model in opposing to what you had in the output generation, although I think many people believe so. Some people are saying that a thinking model, like a reasoning model, isn't necessarily the best choice for the eval, so it's still not conclusive, but just know this, that also the model that you choose for the LLM-as-a-judge and the prompt that is given to the LLM-as-a-judge and the system message are also important, and they are also going to impact the scores or the trajectory of the LLM-as-a-judge, because the LLM-as-a-judge is basically an agent as well, in a way, or just an LLM, so you can say it's not an agent. So, but you get the point. So the LLM-as-a-agent is also non-deterministic, and it also depends on the temperatures that you're using. But this is something important to understand. Now, in terms of rules of thumb, so if you need an objective pass-fail based on a known correct script, like you know what is the trajectory that you want the agent to take, so you use a match evaluator. When you want a quality score, you can use an LLM-as-a-judge to analyze the output. Obviously, in both cases, you are going to use the LLM to analyze the trajectory. Now, I wrote a short cheat sheet, which I like doing this cheat sheet in order to kind of memorize or instill the knowledge in my brain. Sometimes it just simplifies and makes things easier to understand. So let's cover this briefly. So if the situation is that you have a few steps and the order can never change, you want a strict match. If you have all ingredients must be there, but the order doesn't matter, so you choose unordered match. If you have the situation in which you say, I only need to see these guardrails called, so you use the subset match. And if they are forbidden to call extra expensive APIs, so you have the superset match, for example. I'm going to skip the arguments. This is quite clear. These are nuances that you can read more about if you're interested in using a LangGraph. And just two code examples to kind of like make sure that this is clear. This is kind of pseudocode, Python pseudocode. So this is an example for a strict match example. So we have the trajectory of my agent. So he did a tool call search web. The query was temperature Tbilisi. The tool call was send email to yaron@example.com, and the body was 26 degrees Celsius. Now the reference to the golden trajectory, which I wrote earlier, was tool call search web. The query is temperature in Tbilisi, and this is what we expect. Now we create the evaluator. So the strict evaluator is going to analyze the trajectory and is going to grade it based on basically comparing the trajectory of our run versus the trajectory of the golden run. And in this instance, it's going to be passed through because they are 100% similar. Now, another example, LLM-as-judge. So we have the trajectory, why is the sky blue, summarize and return the answer. Then the judge, basically, you are a science teacher, you grade 0 to 1, did the agent give an accurate, concise explanation? So basically, this is the prompt for the judge, how to make the judgments. And now he is providing the score, so he grades it as 0.86, and the explanation is answer correct, but too wordy. Awesome. So quick summary, why this matters? Because if you don't have evals and you're using AI agents or just an LLM in your automation or when you're building, you don't really know what's happening under the hood because it's a black box, and this is why it's so important to analyze the trajectory. So it allows you to catch bugs early. If a code change makes the detective skip an important clue, the strict dance judge fails the test automatically. So this relates to the analogy we had before. It saves you time because instead of reading chat logs, the evaluator can do it 24/7. And it can also measure a scoreboard. So you keep a scoreboard, you have it like the evals, and then when you improve the automation, you have benchmarks that you compare to, and you actually know if you are producing better results now that you've adjusted the agent system message or description, etc. Now take home analogy. So basically building an LLM agent without evaluators is like letting a self-driving car roam in the city with no dashboard warnings. Evaluators add these dashboard lights. Some warn you if the car doesn't follow the GPS route, so for example the match. Others warn you if the overall trip felt unsafe or silly, so for example the LLM-as-judge, and together they keep your robot driver trustworthy. I guess that's pretty much it. I hope you enjoyed this short video, not so short, but I hope you enjoyed this video about evals. I highly recommend that you check out the LangGraph agent eval. They have more explanation over there. And obviously I invite you to check out my newsletter if you're interested in more content about AI agents and automation. It's at nofluff.online. Obviously the video is going to be in the link is going to be in the video description. Let me think what else. Yeah, if you enjoyed this video, like and subscribe, leave a comment below, and until next time, keep on automating.